Hello guys, welcome to Digitronix Nepal 6th tutorial session on Zedboard. Actually, this session is not only targeted for Zedboard, but in this session we will going to create a IP intellectual property like design from VIVADO HLS. That means VIVADO high level synthesis. Actually, high level synthesis is the high level programming design methodology like using C, C++, or OpenCV like languages for creating different type of programs. And in HLS, what we actually do is we convert those C, C++ or high level programs into SDL. SDL usually as well as System C, SDL is PSDL and Verilog. So in this tutorial we are going to work on how to create a custom IP. It will be custom IP actually from VIVADO HLS. This design can be targeted for Zedboard, or we can target for another different type of boards, but we will work on Zedboard for this tutorial. So let's follow the steps. For steps creating project on VIVADO HLS, we will open VIVADO HLS in GUI mode. However, we can do this process on HLS command prompt. We also have HLS command prompt in our start menu. So we are following from HLS GUI graphical user interface 4 steps. So we create this project matrix multiply project. So we are creating a custom IP of matrix multiplier. Actually, matrix multiplier is a program which takes two input matrix and it calculates the multiplication and gives the output. So here is a C++ project file of matrix multiplier. We have used row and column as label for inserting two inputs, and we will compute the product in this section. So after that it will display the multiplication of two matrix. So here is the error file of that C++ program. So we have called matrix multiply.s, and here is the matrix multiply.s header file. In this program, rows and columns are taken as 5 by 5, so it can multiply 5 by 5 type of matrices. So we can also have test bench written in C++. Here is a test bench. So in test bench, what we actually insert is like VSDL test bench or Verilog test picture. We have different simulating steps like stages or like steps of values. So here is also a type of custom matrix like 5 by 5 matrix. We have provided matrix A, matrix B. It must give the output of matrix another, which must have multiplication of these two matrices. So we will follow the steps in VIVADO HLS. Let's look at VIVADO HLS. Okay, this is the VIVADO HLS menu graphical user interface. So we can see recent projects here, and we can also have similar menus as in our VIVADO IPI. So we are going to create a new project. So click on create a new project. Our project name is copied, so this will be project. Actually I need to relocate this project into my project directory. My project directory is a little bit deeper. Okay, I just get that. Okay, this is the project name, project directory. So we will need to add files in this stage. So I will click add files. I have files right here, matrix multiplier and matrix multiplier header, and we can also add C++ files, as I already have shown to you in the previous function. We also can add top level function. Actually, top level function is the main. Okay, actually we don't need to add test bench in this manner, so we just need to matrix mult. So it is the main program and that is here. So we can do next. Here is a test bench edition window, so we can add our test bench here. So after that we can do next, and we can change the clock period. Actually we are going to need 5 nanosecond of clock period from Zedboard, so we don't need to place any uncertainty. However, we need to define the parts. So actually we will select Zedboard. We have Zedboard, so here is Zedboard. Along with Zedboard there are number of other devices. If the device is not in this board menu, so at that time we will need to search by different keywords or different categories. So however we will going to select Zedboard, then we can say okay. Then after we can create a project. After we finish, okay, it will create a project ultimately. Okay, however our project has been created due to multiple clicks on Phoenix. That menu gives some error, which is not need to be considered in this tutorial. So let's go ahead. Here is our main C++ program. This SLS is quite slow than VIVADO IPI. So here is the main program of matrix multiplication. In these two steps it will take an input, and this line is the output. This function, actually function name is matrix multiply, and in this section it will iterate the similar process n times. So this is the main header file which will take the input and provides the output. Okay, and here is a test bench. We already have talked about test bench, so we can go to sources. What we actually need is we should create a SGL file. SGL seems to be here. It is VSGL, Verilog, or System C. So we need to convert this high-level program, C program into VSGL, Verilog, and System C. Actually, HLS can give can convert C program into VSGL, Verilog, or System C languages. So we need to do that steps. So we can see here. It is run C synthesis. Actually, this did the operation of conversion. So aside of that, we can do simulate the our test bench. So if we click the simulation, then let's see what happens. It will simulate the C++ test bench program for targeting this board. Actually it says test is passed, so there is no errors on simulation. So let's go to run C synthesis. This C synthesis actually need to create a HDL program, conversion of C++ program into HDL. So if it create a HDL program, then we can see it here. Let's wait some time for HDL conversion. It is still working on, so let's wait. Okay, it says finish synthesis has been completed. So here is SYN. This must be synthesis menu. So we can see the Verilog, PHDL, and System C, three language converted languages. So if we need to see the Verilog, PHDL file, then we can see here. Actually, this is the conversion of this matrix multiplying program, so which is written in C++. Here we can see there are lots of ports in VHDL. Actually, this conversion of high level program through as LS is not well optimized. It need to be reviewed or reconstructed. So there are lots of ports and lots of variables, constants, which actually need lots of resources in hardware. So we need to concern about this unoptimized code. So it need to be reviewed and recreated. So in these steps we are not going to review on this code, so we are just going to use this code. So this is the main program on VHDL of matrix multiplier. It takes 2 by 5 by 5 matrix, 2 5 by 5 matrix, and gives the product or multiplication of two matrices in 5 by 5 mode. So there are lots of variable, constants, and ports. So it will be difficult to plan on VIVADO IPI for these ports, because we can't plan like some ports are 16-bit ports, so it is difficult to plan this type of ports, output ports. So sometimes there are multiple input ports which which might be unable to plan. Like we can see also Verilog program. That is also similar actually, because these ports are also present in Verilog. Actually, Verilog has a different syntax on module and other statements. So these are the same, and parameters are likewise same. And here is the input and output declaration of ports. There are lots of registers. State machine has been designed. Actually, there is also state machine in this VHDL program. It has also called the component matrix multiplier MAC, which multiply the 2 5 by 5 matrices. There are some generic ports. Actually, generic ports define the different like parameters which can be understand is global declaration in C++. Actually, we can change the bit mode of these generic parameters in here, so it will continuously work on remaining program. So here are some generic VHDL generic feature, and after that ports of this is from matrix multiply this program. So here is a port mapping and state machine in VHDL. We can also see similar program in Verilog. Okay, here is Verilog. We can see similar program in Verilog. Also, we can see the System C programs. So we can see on matrix multiply dot cpp, and this System C. This is actually in System C. This is a little bit different than the main C++ program. So this is the main process of converting high-level program, like using high-level synthesis for converting high-level program into HDL. So let's follow the remaining steps. Actually, we can also see the resource utilization report or synthesis report of this matrix multiplication project. So we can see the timing summary, clock, and estimated time, what type of latency might happen at this program. We can see 686 nanosecond of latency can be happened. So we can utilize, we can say utilization estimation like DSP, FIFO, different IOs, and we can also see different summaries. So what type of direction bits protocol is using, so subsidiaries, and what type of return type does this functions might have. So this is the resource summary or utilization summary. Okay guys, we already have reviewed on synthesis report also. So we already have get a VHDL parallel and system sources from our C++ sources. So we are almost at the last edge. We can also see the analysis, analysis report of this program. So we can change some dependencies at this analysis port, which we're going to talk on another session. So in this session we are only focusing on synthesis and this high level conversion of C++ program into HDL, and we can also see some debugging features of this HLS. Actually this high level synthesis program have lots of features. So our main focus is to create an IP from these designs, from these HDL sources. Actually we already have converted a C++ source into HDL. So what we need to do is go to this export RTL. So we can click on export RTL and we can see the format selection. We need IP catalog type of configuration, and we can also select the language. So if we select VHDL, it will create a VHDL IP catalog based project for VIVADO IPI. So we can click on OK. So after this it will export RTL on our current repository. So we can go to there and see the project. It is still running, so let's wait some few seconds. It might take some time because it will convert these sources into a IP catalog type of RTL. So it has also loaded VIVADO IP repository in data/IP, so we can directly go to VIVADO IPI and run our matrix multiplier IP. So it has been exported in IPI.This format. Actually we need that format, and I just want to see where it has been exported. Here is a directory. Okay, export has been completed, and we can also get our IP from VIVADO IPI because it has already been added by VIVADO HLS into VIVADO IP repository. So we can go to VIVADO IPI also, and we will see the local directory is there is our IP or not. So let's okay, we can see our current repository. Here is our repository of solution 1. We can also see here it has been exported to solution 1. It has also export article which can use for retrieving the IP project in VIVADO IPI. However, it has also exported the project into IP format. So we can see here IP. So this is the main IP format of our matrix multiplier. So we can call if we direct our VIVADO IP repository to here, so it will extract the IP of matrix multiplier. Okay, this is all on this session, so we will continue. Okay, actually guys, we also have opened VIVADO test project. So could we insert that IP we have created in VIVADO HLS in this VIVADO IPI or not. So we are going to follow these steps. For that we need to go to project setting, go to IP, repository manager, add a directory of our IP, which is located actually in XUP and in Zedboard. We have to do it on VIVADO HLS. This is a project matrix multiply. This is solution. Here is IP. So here must be our IP. So it has already get IP. So let's add our IP. So which name must be. So let's go to create block design 2. We should get that IP in IP design. Actually while we export that as RTL of HLS project, that already have sent the VIVADO IPI project. So we can also see here, because this is a recent directory I implement and /IP. So here is a matrix multiplier. So let's see how it seems to be in graphically. So this is our IP. Okay, we can see our IP. So in this tutorial what we have did is we have actually created a HLS project, and we have did the synthesis. After that we get SDL, and then after we export the SDL into IP catalog format with BSDL source. So it has a source of BSDL, and then we export that IP into VIVADO IPI, and we insert that VIVADO IP repository in current project. So this is our matrix multiplication IP, which actually takes two matrices, and then after it will calculate the product and keeps the output like A and B are inputs, and what we get is product in another format. This is the overall tutorial tutorial series on this session. So we have almost created the matrix multiplier. So guys, thank you for watching. We will did the remaining part of how to interface this matrix multiplier with Zinc PS, and can implement on Zedboard in another session. So keep streaming on our YouTube channel, Digitronix.com /p/FPGA, or you can see also on youtube.com/c/Digitronix Nepal. Thank you for watching.